1.3, we have a question that reads, the roots of an equation are x is equals to minus n plus minus the root of n squared minus 4mp over 2m, where m, n, and p are positive real numbers. The numbers m, n, and p in that order form a geometric sequence. Prove that x is a non-real number. So here we are tasked with proving that x is a non-real number. And they also tell us that m, n, and p form a geometric sequence. Now under sequences, we know that geometric sequences have a ratio. This ratio states that term number 3 over term number 2 is equal to term number 2 over term number 1. In this case, if we were to arrange this, we would have m, n, and p. This is term number 1, term number 2, term number 3. So, using the knowledge that this is a geometric sequence, we are able to create such an equation. We have p, which is term number 3, over n, which is term number 2, is equal to term number 2 over term number 1, which is m. Then from this we cross multiply, we'll get n squared is equals to pm. Now 1.3 on most question papers is regarded as a difficult question, as it requires you to understand a bit more than algebraic logic. So here the key is that at the end of this question we have to prove that x is a non-real number. How can we tell what the nature of numbers is? So under the topic nature of numbers, we have this formula called the discriminant, represented by this delta sign or the triangle sign. This states b squared minus 4ac. Now if we are to prove that x is a non-real number, we have to prove that the discriminant will always be less than 0. If the discriminant is less than 0, we can say the roots are non-real. So we continue. Here b squared minus 4ac can be found underneath our square root sign, and it's n squared minus 4mp. Now we can simplify this a bit by substituting mp with mp over here, which is n squared. We're gonna have n squared minus 4. Remember, mp or pm doesn't really matter which order you write it in, it's all the same. So replacing mp with n squared, I have minus 4n squared. This gives me minus 3n squared, like that. And this will always be, this discriminant will always be, if we analyze it, it's made up of two parts. One part, n squared, will always be positive, right? If n squared is always positive and we always multiply that number that is positive by negative 3, then this will always result in a negative number, because multiplying the result of this, which is always positive, with negative 3, which is always negative 3, it will always turn our number negative. Therefore, we can say discriminant will always be less than 0, and x is non-real. And there is nothing specific about the substitution we made over here. Here there are two ways in which we could solve this. So instead of making a substitution for mp, we can make a substitution for n squared. So that would be over here. If we were to do that, then instead of having our n squared, we would have mp. minus 4mp. Again, we get minus 3np. And what we're told about mp is that m and p are always positive. So we can count on the product of these two numbers being always positive. Then minus 3mp will be less than 0. So if we multiply this number that is always positive by a negative number, then the result is always negative, and then we can come to the same conclusion as this one. X will be a non-real number.